Hey guys, welcome back to another video. It's just math, y'all. We can do this. Alright, today we are going to be looking at functions. We're going to look at introduction to functions, okay? Alright, let's see. Here we go. Introduction to functions. So we got a couple of vocabs that we want to look at. Before we jump in, don't forget to look at your objective sheet. Now I'm going to go through part 2, A, B, and C. And then you find another set of videos on D. Okay, so let's get started on this. 2A, B, C, and D, introduction. All right, back to our PowerPoint. So these are some vocab. We have what we call a relation, which is just a set of ordered pairs. Now, a relation can be special. It's called a function if it's special. And this is where each x has only one y. We talk about that we can't have a 2 times an x. We'll look at some of that in a few minutes. But x can only have one y. And that's it. So we have to look for that. Now the domain is the set of all possible x values for a relation. And a range is the set of all possible y values for a relation. So now relations or functions can come in different formats. And so we have to be able to look at different formats of relations. So 3 different formats are here. We have a list format, equation format, and we have graph format. And so let's look at each one of these and determine if they are a function. In the list category, again, the key to the relation being a function is only each x has only one y. So this is what we're looking for. We're looking for repeated x's. And so if we see here in the list of the x coordinates, the 3 is repeated. So this is not a function because the 3 is repeated. So now when we look through the next one, if I look at my x's, there's no repeating. So this one is a function. And then the last one, let's look carefully. 3, 7, 8 looks good, but hey, 4. It's got a repeated y. Is this a function? Yes, it is a function because it does not matter if the y is repeating or not, just if the x is repeating. So we're looking for no repeating x's. No repeating x's or no 2 timing x's. Alright? Now, in an equation, what we do to determine if something isn't got a repeating x or not is we solve it for y. If we can solve it for y and we don't have 2 things, then it is a function. So now obviously the first one is already solved for y, so yes, it is a function. Now the next one, it's not solved for y, but I could solve it for y without too much trouble. I would just have to divide both sides by x, and then it's solved for y. So yes, it is a function, because I can solve it for y. And then now the third one, this is the one that's not a function. Because if I try to solve this for y, I have to take the square root of both sides. So if I take the square root of that, that's fine. But we also remember from our last unit, when we did the square root of both sides, we always had this plus minus thing going on. And we always ended up with 2 answers, a positive one and a negative one. And so this one is not, it's not a function because there are 2 x's here, okay? So, 2 answers for a single x. All right, so it's not a function. Okay, now for graphs, we have a little vertical line test. I'm trying to find a good color. I'm going to try this green. For the graph, we do the vertical line test. And basically, we just draw a line through the middle of our function and see if it crosses more than once. And so when I take a vertical line and run it through here, it's only going one crossing. This little green line is only crossing in one place. Whoa! I can't get it to do what I want it to do. Oh well. That little green line is only crossing in one place, so yes, it is a function. Yes, function. And if I did it over here, only one place. No matter where I draw that line, it's only crossing at one location. So yes, function. Same with this one. If I draw it here, it only crosses once. If I draw it here, it only crosses once. So yes, it is a function. But this circle, if I cross it, has two partners. So no, not a function. Again, we're looking for that double x, the 2 times an x. And so that's what that vertical line represents. We could just pretend that vertical line on that circle would say -2. That vertical line represents -2, and I've got a point on the north side and a point underneath, and I've got 2 values for x, so it's not a function. Okay, let's keep moving. So that's your introduction on how to determine if a function from a list, an equation, or graph. We did the 2a. All right, let's move on to 2b. 2b says determine the domain and range from a graph. Now this is the hard one, and we need to use interval notation, so this gets kind of tricky. So we want to use interval notation for this. Now I've imported some graphs, and we're going to look at these. So the domain is all your x values. So this first graph, if we'll look at it, we start with our domain. Our domain is the x-axis. So if I look along the x-axis, I see that this x right here, which is -7, it has an arrow down here. So in reality, it keeps going. And all these points, all these x points, all these x's have members of the graph. All of these x's have y partners. All these x's have y partners, and the arrows indicate that all the x's have y partners. Okay, so now we learned how to do interval notation with our graph, and so this would be left to right. For this one, the domain would be -infinity, because that's the left, to +infinity. That's all real numbers. Now the range is the y values. Now this one's harder because we're not used to doing a y number line, but the y number line is an up and down number line. We have the arrows up and down. This is -infinity, and this arrow here is +infinity. And when we do up and down, we do bottom to top. We always do bottom to top. When we're doing domain, we're always going to do left to right. In domain, we're doing bottom to top. So the bottommost point on this graph, well, I've got arrows down here. Technically, it keeps going. And this one's going to keep going up. So I have a point down here. There is a y value. It's way down there, but it is going. It is getting slowly further and further down. Okay, so I do have a y value. All right, so that's -infinity. And then all these y's have values. Now it appears to stop, but this arrow also seems to be continuing up. And so these are going to also go up. So from bottom to top, I'm also -infinity to +infinity. All right, that was pretty tricky. Let's look at this one down here on the bottom. This one's number 2. So now the domain on this one, again, we're going to do left to right. Let me get back to my purple color coordinate. The domain, again, is left to right. And so now the left stops. There is a stopping right here. It's not crossing that line. And I know that, but you may not know that. So from the left to the right, it's 0. It does not go anywhere. None of these have this. This is going straight down. So it's 0. And it keeps going to positive infinity. And this, we don't know if it touches 0 exactly, so we're going to leave it not touching 0. So my domain is 0 to positive infinity. Now we'll do the range. Now the range is the y values. Now obviously it's going way south down here. And obviously it's going way south, and all these y values are occurring. But my question is it going to continue to grow? And it does. It may grow off the paper. It may keep growing, but I still am getting taller and taller. So yes, my y value is growing. So my range is negative infinity to positive infinity. Okay. All right, now, number 3 is very interesting because I pulled it in here because I wanted you to understand that domain is not always an X number. Domain represents real things, and when we do real life math, sometimes domain is not always numbers. This particular case, our domain is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. That's our domain. So we would write that. Now you don't have a question like that on your homework, but I wanted you to see that your domain would be the set of the days of the week. That would be your domain. It wouldn't be an interval notation because it's not from a number to a number. It's days of the week. But our range is numbers. And we can look at this to see that my range, my lowest number of the whole piece of graph is 10. And my highest number of my whole graph is 35. So my range would be from 10 to 35. I'm getting my orange because range is orange, right? Why did I make range orange? I don't have any idea. But 10 is a point, so it gets a bracket. So 10 to 35. That would be my range. All right, now this last one, I've got some covered up pieces too because I couldn't find a really good graph that I liked, and those have those extra things, so just try to bear with me. The domain and the range of this one. Now this one does not have arrows, okay? The domain, we do not have arrows. So my domain starts at -1 and stops at 2. That's the domain, and it's from -1 to 2. And then my range, it's bottom to top, and my bottom number is +2, and all these y values have members of the function, and it stops at +2. So my range is -2 to +2. So that one was a little different. I wanted you to see. That one didn't have arrows on it. Okay. So those are some things. Now this is very confusing for some people. So you really are going to have to work on this. Really going to have to work on this. Here's what I need you to remember. Domain is left to right. Range is bottom to top. If you'll focus on that, it will help. Domain is left to right. Range is bottom to top. Okay, come back and join us for another video soon. It's just math, y'all. You can do it.